Okay, hello everyone and welcome back to Technically Unsure, where I'm not really sure what I'm doing technically.
I'm sorry, we seem to be having some technical difficulties.
Today I'm going to try something totally different than my usual content. I do that because when I was reviewing one of those SBCs, it did have one binary in it, and I used Ghidra to basically reverse engineer it and went through it a little bit. Seems like you guys liked it, so I just want to try a little bit different type of content, a little bit educational content. So if you guys enjoy this one and like this one, let me know. I will probably make more similar videos to this one. I just want to give it a shot, see how you guys like it, and then take it from there. For today's video, I just want to talk a little bit about binary files, Windows applications mainly, and then also shellcodes and what they are. We are going to try a little bit Metasploit and some other things just to cover binaries, shellcode, and what they are. In order to do that, I just want to first give you a little bit background information about the binary files, right? When you compile an application, you write a code in C, C++, you compile that, you get a binary file, you get an exe file, let's say, in Windows. Can be maybe, I don't know, DLL, OCX.sys driver, but let's talk about exe files, the executable Windows applications. If you want to execute that, you just double click on it and it runs, right? But inner workings, right, how Windows loads that and how it does what it does. Let's say it shows you a message box, how that happens. All that is handled internally with API calls and basically talking to Windows and making some function calls, and Windows does that for us, right? But what that file is, right? What does it look like, and the library calls and stuff. So I just want to show you very quickly. For instance, if we open up a Visual Studio, right? And I have a console app I just created right before this video, but I guess we can create another one. So you just basically create a C++ language and the console app that literally just runs and shows hello world and I don't know, test application. And yeah, there you go. So we get this application. It literally does nothing other than printing hello world in the console, right? And if we go with the release build, for instance, and if we compile this, okay, look what happens. If I compile this and if I open this up in my Explorer, and you will see this alone is 13 kilobytes, but that's not really how much that is, because you will see that it is not standalone. It is using some other libraries, which is going to be the C++ runtime libraries, right? So if I open up the PE Studio, okay, and if I drag and drop this, so PE Studio is a tool that I usually use when want to take a look at an application, and it tells you the libraries it is using, the imported functions, and all that stuff. So if you go to the libraries, you will see immediately MSVCP 140 and VC runtime 140, right? So it is using, and there are API-MS-Win CRT and this, all that stuff. So this application, 13 kilobyte, is not standalone. It requires your computer to have Microsoft C runtime library. And that's what happens usually, like when you're installing some game or some application, you will see that very quickly it flashes and it does stuff and it is installing C runtime library. That's what it is. So they compiled the application, they wrote the code in C, compiled it, and they used the compiled flag, and it keeps the file size smaller, but it relies on the runtime. It relies on the C++ runtime. So if you don't want this, we're gonna close this. If you don't want this, you can go to your project settings, right? And go to the C++ and code generation. You will see that in the release, you can turn this multi-threaded DLL into multi-threaded. And then if you compile it again, rebuild, okay. And if we go back, you will see now it is 196 kilobytes, right? And if I open up the PE Studio, you will see if I go to libraries, you will see that there is only now kernel 32, and it is calling like a bunch of functions from kernel 32. Did I write any of these codes, any of these functions? Am I importing any of these? No, but the way that I compiled, that's how it is, and now it is using all these things. It's just skeleton calls, whatever, just to get things done, and it is literally just doing a hello world. And keep in mind, if you want to do this standalone thing, like in any other library, any other language, it might be bigger, or size will be larger, or it might not be even possible. Like, let's say, I don't know, Python, you want to compile it, you need another application with Python interpreter in it to turn it into exe, and then you run it. So C++ is the most, standalone language you can get in, like, at least in Windows and many other platforms too, that the application will carry everything that it needs in it, and you will be able to just double click and it will execute. Okay, so all that stuff, right? I just wanted to show you the size, the sheer size of an application when you want to make it completely standalone. Now, let's talk about when let's say there's a vulnerability in an application, and now after you gain control of the execution, now you want to execute some code, right? You want to arbitrarily execute some code, take advantage of the vulnerability and execute a code. Usually what security researchers refer to that is going to be called shellcode, right? So shellcode is a location independent, and you can execute it at any moment, at any point in execution flow of the app, and it will still execute and do the instructions that you write in the shellcode. And it's always written in assembly. And as I said, it's in a location and place independent. So it can be in middle of the application because it is not linked to application's import address table or the libraries that the application is using or built with. It is totally independent. It will get executed anywhere as long as you get the execution to that code. So how do you generate that? So one of the most common ones that at least I use, and many other people I know they use, is going to be Metasploit, right? And in order to have Metasploit, you can install it on any operating system. But I have Kali. I just downloaded literally from the Kali website, and you will get this Kali. So I'm gonna zoom in post, so hopefully you will have a larger screen for you. So what I'm gonna do, let me make this bigger. The application that we are going to use is called MSF, which is Metasploit, and then Venom, okay? And it actually gives you a lot of other parameters. We are not going to use that. That's for 32-bit. So what we are going to do is we are going to generate a shellcode for platform Windows, okay? And then architecture is going to be x64. And we are going to say the payload is going to be the Windows x64 and execute. So we are going to execute an application, execute an app, right? And the application that we are going to execute is going to be calculator.exe. And the format of the output that I want from MSF Venom going to be in C. So C++ language, right? And if you run this, there you go. So it is going to give me raw payload, no encoder used, and it is going to give me this raw payload. And what you see here is a 1188 bytes, and this 1188 bytes will, when you run it, it doesn't matter if it's middle of application, end of application, beginning of application, as long as the code execution in CPU cycles gets through the first one and just goes through one by one of these instructions, it will execute calculator in your computer. So that's how, when there is a vulnerability and you get to the execution, shellcode execution stage, you need a shellcode that's written in assembly, location independent, and it will be executed and it will do what you want it to do. So there are various payloads. There is a payload for backdoor, command prompt access listener on some port. Whenever you connect to it, it will give you shell access and so many other things. So we are just going to cover the basic. I just want to mainly talk about the binary, right? So we get a calculator executing shellcode in here, okay? So if I copy this and go back to my host machine and open up the notepad, right? If I paste this in here, this is the shellcode, right? So what I do is I'm going to remove the, all those stuff that I don't need, and I'm gonna make it single line, okay? A whole thing. That's my whole shellcode, okay? Now if I open up a debugger, right, x64 debugger, and I guess from the desktop, okay, actually, you know what? Let's open up our test application. If I open up our test application in here, so this is the main beginning of our entry point of our application, okay? If so we have the shellcode in clipboard, right? I'm gonna copy that. And I have this in here, and if I scroll all the way down, if you copy more, it's better, it's fine. If you select more, it's fine. So I'm going to do binary and paste. So if we go back, you will see, okay, it changed a bunch of shellcode, it replaced with shellcode. Bunch of opcodes that were in the original application are now replaced with my shellcode. If you look at it now in here, if you go beginning, you will see that FC, 48, 80, 83, E4, F0, okay? So basically my shellcode is written in the entry point of this application that we just compiled, right? And if I now execute this app and I say continue, you will see that it popped a calculator, right? So my application did not have import for winexec function, right? It does not need. It's a location independent shellcode. It works and gets executed anywhere, and it will do what you want it to do, which we asked for it to execute a calculator, and it exited the process. Still, you want to, let's say you want to create a binary that will execute that shellcode, right? If I want to do that, I will probably have to go back to C++ and write a function, an application that will do virtual allocate and allocate a space in the memory, then write my payload, my shellcode into that allocated memory, change the permission of that page with virtual protect API, and then create a thread and execute that shellcode. Give me a couple minutes. I'm going to go into fast forward mode, and I will show you what I'm talking about very quickly, okay? Okay, so I wrote the skeleton, kinda. So let me remove that and regenerate, or just get it from here. Yeah, so unsigned char, and we have this. I am going to put that in here, rename that to payload. Okay, so here's what it looks like, generally speaking. Okay, so what we have here is basically the shellcode that I just got from the Metasploit, and I calculate the length of it. I can put a static or just use size up. And then in the main function, I am basically doing a virtual allocate. I'm allocating in the size of the payload length a memory page, and I'm putting that the pointer here, and then I'm moving and copying basically what I have here in my application as my payload into the page that the memory page that I just allocated, and then I'm changing its permission that I'm allowing execution. So I'm making it executable. And then if I'm successful in allocating the virtual memory and making it executable, I'm creating a thread, and the beginning function of that thread is pointing to the memory page that I just allocated. So if we go back to debug, let's see if I messed up anything. What we got a pointer to some page in memory. We copied it, and we were able to protect the page, change the permission of the page, and make it executable. And if I start it, ta-da, we got a calculator. Okay, so this application, which is a virus. Okay, so now I just basically created an application, a skeleton application to execute. Oh my god, please let me go.
Just let me go.
So what we did was we basically created a skeleton application that will execute arbitrary shellcodes generated from Metasploit or anywhere else, right? So if I compile this application, obviously, so the application is open in here, obviously, so we have to close that. And now let's rebuild it. And if I go back here, you will see that it is 105 kilobytes, okay? So this application is standalone. If I open up the PE Studio and I put back the exe in here, you will see that in the libraries, there is nothing. That means if I move this application to any computer that's Windows, it will work, okay? I think like starting from Windows XP or maybe even earlier, Windows 2000, something like that, this one should work as long as it's 64-bit, because we generated a 64-bit shellcode, okay? And the application, okay? It's just wanted to show you how all these stuff work. Now, what I want to show you is some final magic. So, what I did was, I basically created a Python script that I used in conjunction with assembly. So I created this function, this application. This is basically a malware, right? What it does is, it is shellcode. It does not have any functions in the import address table. It is not using IAT, and it is not using any framework. It's all written in assembly. It will just resolve all the API functions that it needs itself, and then it will make a bunch of API calls. And those API calls are basically written here. It will allocate again, it will use the virtual allocate, and it will use get module file name to find itself, the application exe name, whatever it is. And then it will use the exit process to exit when it's done. It will use a copy file because it's going to copy itself to another location, and that location is Windows directory. So it will copy itself to Windows directory and then execute, so it will always stay persistent. And the application is going to be Windows directory /virus.exe, okay, Winder and virus.exe. It will copy itself there, and then it will also use load library A API function from the kernel, and then load adva-p32, which is used for registry stuff mainly. And then it will use reg create key, reg set value, reg close key to actually create a startup item, which is going to be in the current user, and then software Microsoft Windows current version run, which is a startup item, right? And it will put the C Windows virus.exe in there as a startup item. So basically every time you reboot your computer, this virus going to run, okay? And then what else it does is basically just shows you a message box on your screen, and it will say infected. So that all that being said, it means it will it will find itself where it is being executed. Is it executed from like the downloads folder, C users, technically unsure, the application.exe, is it there? Whatever it is, it will find itself, its exe file path, and then find the Windows directory, copy itself to Windows directory with C Windows virus.exe, create a registry entry that is in the current user, and then software Microsoft Windows run, current version run, and it will always run at every reboot, and it will just show a message box that says infected. That's it. So it's not much, I get it, but it is something, right? And it is completely and then it calls terminate process. It is entirely written in assembly, and you can run this without any problem in any in any version of Windows, okay? So in order to compile this application, I'm going to open up the command prompt, go to desktop, right? So first thing, I will assemble it with NASM, right? So I will just do NASM and I'm gonna say it's for Win32, and it's going to be the viri.assembly. Okay, so if I open up this folder now, you will see that I got an object file. So it is a compiled application, compiled code, but it's not really executable. We need to link it now. So in order to do that, so I'm going to use the link application and say subsystem and say it is going to be for Windows. And entry point is start. That's what I wrote in here. That's the function. Okay, so you change it to something else, that's going to be something else. Entry is start, and we are going to use the test.object. Sorry, not test.object, viri.object. Object. Okay, there we go. Now, if we go back to desktop, you will see we got a file. And if I open this file properties, you will see it is 1,536 bytes. It is almost as the same size as the shellcode generated by Metasploit. The whole thing is 1.5 kilobytes, so 1,500 bytes. And it is completely executable, and it is a standalone application. So if I open up the PE Studio again, okay, and move the Viri in there, you will see in the libraries NA, there is no imported library. There is no library, no imports, no dependencies. It does not need any application, any DLL, anything, and it will just work. And you will see it detected a bunch of strings, but as you see, it is all written in reverse order. That's what I use this Python script for. So I'm pushing 4 bytes at a time into stack for API names, and then I populate and you load and use that. So for instance, you will see here, get module file name. It is basically every 4 character in reverse order. I'm just pushing it into the stack, and then I'm populating that and using that variable. That's why it's all messed up, which is good actually. It's kind of like a bypassing AV as well, right? So it is all in that order. So you can do that with my script. So if you do like Python, what is that, API name .py, and then say load library A. Yeah, this is what it will generate for you. So you just copy paste that in your assembly code. You can generate as many functions as you want this way. So it's a standalone application, very small, and it works. So if I want to show you that, if we go to desktop and if I double click on it, there you go. You see the infected. It's not just that. Let me execute that with administrator permission. So back in the day, okay, you did not need the admin permission, but now you need. So if we go to Windows folder and if we go to virus, you will see it copied itself to Windows directory as virus.exe. And if we go to regedit and current users, software, Microsoft, Windows, current version, run. There we go. Viri and virus.exe. So every single time I restart the computer, it's going to show me that infected message. And I wrote the whole application in assembly and compiled it, and it is 1,500 bytes. And it does all that stuff. And it works. It should work. This code should work from Windows 2000 plus. So Windows 2000, XP, 7, Vista, 8, 8.1, 10, 11. This is 11. So what I'm using is Windows 11, and it just works. Yeah, I just wanted to share this with you guys. I hope you guys enjoyed it. I enjoyed it, certainly, making it. Yeah, so I covered pretty much multiple topics, right? I covered a little bit about shellcodes and the payloads and MSF VNM. And I talked about the binary and how you can, execute arbitrary shellcodes. And we even wrote a small shellcode execution stuff, which I stole off of the internet, and and this is stolen from Metasploit. Yeah, so combined together, we covered many topics. I hope you guys enjoyed it. I pretty much this is what I used to do. This is what I do usually in my job. Not necessarily this, but cybersecurity and cybersecurity research. So yeah. Let me know if you guys want me to do any more similar videos to this. So this is the uncommon to what I have been doing in this channel, which is usually like the board, SBCs and motherboard and stuff review. But you guys let me know. If you enjoy this type of content, I will make more of it. And if you have some specific topic in your mind in cybersecurity area, let me know. I will try to make video and answer your questions. Anyway, thanks for watching, and I will see you in the next video. Bye for now.